Hello, in this tutorial I'll show you how to solve question 5 of sample midterm for CS3340B. To do this question, you just have to fall back to the most efficient sorting algorithm you know, which is merge sort. And you could of course use heap sort if you like, but they're both n log n, but I prefer merge sort. Now, we have a list, okay, it has n elements that are sorted, right? So you have something like that. You have your first n element. These are n sorted, but then you have f of n not sorted. So maybe I'll just use a different color. Okay, so you have a bunch of other ones, f of n unsorted. So the idea is that you'd like to sort the entire list for a bunch of f of n's. Okay, so we look at 5a first. F of n equals to 2. How do you sort this one? How do you sort the entire list? Easy. So, well, compare the two elements and swap to make, well, if necessary, if needed, to make the entire list sorted. Okay, 5b, f of n equal to the square root of n. So that means there is n sorted and then followed by square root n unsorted. Well, again, same idea, but this time use merge sort to sort the square root n elements. This can be done in square root n log of root n time. Okay. Next, merge the root n elements with the sort with the n elements in n plus root n time using the merge procedure of merge sort. Okay, this one is not that difficult. Now for 5c, how large can fn be for the entire list to be sorted in big O(n) time? Okay, so if you actually do some math, you'll notice that for root n, we could do this work in linear time. To show this, first of all, notice that the log of root n, this is same as log of n to the half. Half comes out, you have root n log n, and actually log n is lower than root n. So this is just big O root n. Okay, so the sort is big O root n times root n, which is big O n. So the sort can be done in linear time. And we know root n is less than n, so the merge is linear time. So all of this work can be done in linear time. But actually fn equal to root n is not that small. There is a bigger one. Okay, for this question, we're looking for fn. So we need fn such that fn is in, well, fn log n log fn like that is in O(n). This is what we want. So what do we do? Well, notice that we could, we could pick fn to be square root of n, for example, but that's way too small. We could do better. In fact, the best that we could do is something like this. Oops, what's happening? Okay, so if fn equal to n over log n, we'll have some cancellations happen. So basically this is engineered so that we could have cancellations. Okay, then you could do n over log n log n over log n, which equals to n over log n. So remember, log of a division is the difference of logs, so that's log n minus n over log n log n. So clearly if we add to something, we make it bigger, so this is going to be less than or equal to n over log n log n. So essentially we just get rid of the minus by adding. When we add, this is going to be smaller. Stuff on top is smaller than the stuff on the bottom, so we have n log n here. Well, of course these logs cancel out and we get n